Let us look at an example which illustrates the different equations we've seen in the previous lecture. So in this example, we have a car which starts from rest with a constant acceleration and achieves a velocity of 15 meters per second when it travels a distance of 200 meters. We're asked to determine the acceleration AC and the time required to get to this velocity. So I'll give you a couple of minutes to think about this problem, and if you feel like you can actually solve it on your own, by all means go ahead. The very first thing one needs to do is to select a coordinate system. Now here there's no confusion since we know that we're dealing with a rectilinear motion, and that's only 1D, so there's no need to worry about which coordinate system to use. We know that we're working in 1D. The next step is to write down the different variables, or what we know. So we know that the velocity is 15 meters per second at s equals to 200 meters. We know that the acceleration is constant, but we do not know its value, and we do not know the time at which the velocity is equal to 15 meters per second. Now, the thing that I like to do after that is to write down the different variables I know and the different variables I don't know, and see which equation I can actually make use of to find one unknown. Remember, each equation allows you to solve for a single unknown. So whenever you want to use any of the equations we've seen before, you need to know all the other variables except the variable you're looking for. So in that case, we have the velocity and the distance. So I can write down Vs with a third unknown variable that we need to pick. Now, remembering which equations we know that includes Vs and one of the two unknowns we're looking for, one remembers that we actually worked with an equation which includes Vs and A, and that's basically the equation that's independent of time. Now, what other equations you can think of? Well, you know that we have an equation that relates V, A, and T, but it does not include S. And remember, we cannot have two unknowns at the same time, A and T. So the only equation we can make use of is the equation that's independent of time, and it states that V squared is equal to V0 squared plus 2AC S minus S0. We know that V0 is 0 since we're starting at rest. We're still looking for the acceleration. We can set S0 to 0 and S to 200. And solving for A, given that's the only unknown in the equation, we'll end up with a value of 0.5625 meter per second squared. So now that we've solved for A, it's time to solve for the other unknown, which is T. And now we need to, again, make use of an equation that includes all the variables we know and the single unknown we do not know, which is time. So we have V, A, S, which are known, and T, which is still unknown. And so the only equation we can make use of is the equation that relates V, A, and T, and that's the velocity equation, right? Because we know that for a constant acceleration motion, we have V is equal to ACT plus V0. And since we know A and V, we can easily solve for T, assuming V0 equals to 0. So T is equal to V minus V0 over AC, which is equal to 15 over 0.5625, and that's equal to 26.7 seconds. So as you can see, when solving problems, it is always necessary to understand the different equations you have. If you feel like you cannot memorize which variables are included in whatever equation, make sure to write them all down, or you can make use of the formula sheet, which is available at the end of the book. And so you can look at the different equations and see which equation actually includes a single unknown and all the other variables are known. This equation can be actually used to solve the problem.